Lesson 2-4, Solving Equations with the Variable on Each Side. I'd like to start this lesson by having you answer your bell ringer here on the computer. I want you to explain in your own words how solving an equation can be compared to unwrapping a present. Alright, now that you have done that, for today we will solve equations with the variable on both sides that involve grouping symbols. And by the end of the lesson, you will be able to solve an equation with multiple steps. First, I'd like you to take out your textbook and skim the examples in this lesson. Predict 2 things you think you will learn about solving equations with a variable on each side. Now, let's review some vocabulary. First, equations that have the same solution are equivalent equations. Remember, this means that both equations will have the same answer for the variable. An equation that requires more than one step to solve will be your multi-step equation. Integers that are in counting order are consecutive integers. If you'll remember from the previous lesson, an example of consecutive integers would be 1, 2, 3, just numbers in counting order. You could also have consecutive even integers. Examples would be 2, 4, and 6. Or consecutive odd integers, which would be 1, 3, 5, and so forth. The study of numbers and the relationships between them is number theory. A rule for the relationship between certain quantities is a formula. And finding the value of the variable that makes an equation true is when you solve an equation. Now I'd like you to look in your textbook and define identity in your own words. An identity is an equation that is true for every value of the variable. An example of this would be 2x plus 4 equals 2x plus 4. If we were to subtract 2x from both sides, we would get that 4 equals 4. So no matter which value we assign to x, the equation will always be true. Now, as you're solving an equation, how do you know if an equation is an identity? Take a minute to answer this question. An equation is an identity when, while you're simplifying the equation in order to solve it, you get down to the point where the left side equals the right-hand side. So if you had an equation that said x plus 3 equals x plus 3. Of course, both sides of this equation are exactly the same. So no matter what value you give to x, your equation will always be true, and therefore it is an identity. Now let's talk about how to solve equations when you have more than one instance of x, especially x on both sides of the equal sign. So the first thing we want to do with this one, we got to get rid of those silly parentheses. And the way to do that is using distribution. I'm going to distribute the 7 across the parentheses, which means I'm going to take 7 and multiply it by each term inside my parentheses. So what I get is to use the distributive property, and that gives me 14x minus 21 equals 12x minus 5. The next thing we want to do is get all of our x terms on the same side of the equal sign. So we need to subtract 12x from each side and simplify. 14x minus 12x gives us a remaining 2x. Now let's look at our next example. 6y plus 4 equals 3 times the quantity 2y minus 10. The first thing we want to do, once we have an equation like this, is remove parentheses. We do this by using distribution. So I'm going to distribute the 3 to both of the terms inside the parentheses. So first I'm going to copy down the left-hand side of my equation, put my equal sign, and then actually distribute. 3 times 2y is 6y, and 3 times negative 10 would be 30. The next thing we're going to do is add or subtract to get the variable on the same side of the equal sign. In this case, this means subtracting 6y from both sides. And I'm left with 4 equals negative 30. Normally at this point, when you're solving an equation, you'll just solve. In this case, there's nothing to solve. Our variable's gone away. And we know that never does 4 equal negative 30, which means that for this equation, there is no solution. There is no value for y that we can plug in and make this equation work. Now I want you to solve this equation on your own. Remember to follow the steps we covered in the notes and tell me what r equals.